let us begin. What is metal forming? Essentially, metal forming is the process ambayo we deform metals plastically. Ama material is deformed plastically to change the shape. When I say plastic deformation, I mean the permanent deformation of a material because of stresses, be it compressive stresses, be it tensile stresses. Yeah, and we can deform a metal using dies. Dies are tools that we are going to see in these videos and in also the next videos. Are tools, the dies, the punches, depending on the type of process that you want to undertake. So when we talk about these metal forming processes, we can classify these metal forming processes according, let me confirm, can you see this table vizuri? If you can see it, please unmute and tell me kama mnaiona.
Just somehow bit. Unless ukizoom kidogo tunaweza iona, ukizoom.
Okay.
Yeah, that's better.
Mnaiona vizuri sasa?
Yeah.
Okay. Now, we can categorize metal forming processes as sheet metal working and bulk deformation. Sheet metal working is when you're dealing with very small work pieces, but we can deal with huge. Ama kazi ni mingi, so we can we can categorize metal forming as under bulk or sheet. Under bulk deformation processes, we have a process known as rolling, kuna forging, we have extrusion and wire and bar drawing. We will see each of these processes ambavyo zinafanywa. And then under metal sheet metal working, we have bending processes, we have deep drawing ama cap drawing, we also have stretching processes, shearing processes and any other processes ambazo do not require huge work pieces ama huge metals. Now we will discuss each of these one by one briefly. Now rolling process ni kama ile, I'm sure you have seen the vendors ambao wanatengeneza juice za miwa. There is that machine they use. That is a very good example of rolling. You have a metal workpiece or you have a workpiece that is being drawn, inavutwa between two rolls. Yeah? And then that workpiece or that whatever is being drawn into that machine is compressed. In a change shape and it forms a sheet. That is what we call rolling. I will play a small video over here so that we can see what rolling entails. So please tell me kama mnaweza ona hiyo video vizuri. Let me mute Martin. Okay, I will play a video. Please tell me if the video is clear. Now, tumeona hiyo video. I hope imetokea clear. Was it clear? Hamjaona kitu?
Sijaona kitu, imekuwa tu black.
Kuna mtu mwingine
Mimi screen black.
skin ilikuwa black?
Haija play kitu yote.
Okay, let me see whether we can fix that. Lakini sauti mlikuwa mnasikia? Okay. Unaona sasa, can you see my screen?
Yes.
Okay. Unaona chochote? Okay. If kama kuna shida, please let me know ndio tusiendelee na muoni. I think we have gotten the idea of what rolling is. You take a workpiece, or you take your metal ama ni mbao, hata ile ni miwa, ile watu wa miwa wanatengeneza juice nayo. You put it in rolls, those cylindrical dies, and then they compress the workpiece. That is what we call rolling. Now, we have forging. Forging, I'm sure most of us are familiar with it. Pale kwa blacksmith, kwa mtaa. When you take a metal workpiece and you compress it between two dies. The dies, when I talk about a die, ni hapa juu. This is your workpiece, your metal. That die mfano has a particular shape that you want to impart, ama unataka kuweka kwa your workpiece. When you put your workpiece in between these two dies and you hit or you apply a force onto that die, that is what we call forging. You're compressing the workpiece between two dies. There are so many processes of forging, but for now we will just briefly pass through the meaning of forging. We have another process which is known as extrusion. Okay, this is a process in which your workpiece is being pushed between a die that has a kuna shimo hapa. When you push your workpiece, it must the cross-sectional area of that workpiece decreases. So that is what is known as extrusion. So that area can be of any cross-sectional shape that you want it to be. Unaweza kuwa with a cylindrical workpiece, but your hole kwa hiyo die is rectangular ama ni triangular. Sana sana this is done to workpieces. Mfano, if I give you a circular pipe and I want to change the shape to rectangular ama square, utachukua your workpiece and then you push it through a cylindrical, a rectangular die that has a rectangular cross-section ili change shape. Now I will play a video so that we can see how extrusion is done. Let me know if you can see it. if you can see the video.
Yes, you can see.
Okay, thank you. Now, that was just a very short video that shows how extrusion is done. Give me a minute, I admit someone. Now, there are some terms that have been mentioned up. You don't have to be usisumbuke nazo sana, those terms, billet and ram. But in this diagram, as you see it hapa juu, this part, the ram, is what will be pushing your workpiece through that cross-sectional area. That is now the basis of extrusion. You push your workpiece through a cross-sectional area of your die. Now, we have another process known as wire or rod drawing. It is the same as extrusion. Now, the only difference is you're not pushing your workpiece, you are pulling it. You apply a force on the other side of the die and you pull your workpiece. This F represents the force, this V represents the velocity at which you are pulling your workpiece. Now, as we have seen in that video, the force applied will be dependent on the type of material that you're pushing or pulling and the friction. So we can reduce that force by applying lubrication within the die. These spaces up there, you can apply lubricant to reduce the force. That is what we call wire drawing. You pull your workpiece through that extension, through that die, the cross-sectional area of that die. Now, we have another process known as bending. You take your sheet metal or your workpiece, place it on a die. You push, and then you push that sheet metal using a punch. A punch is a type of tool that we use in the workshop. We will look at them in the next topic. You apply a certain force, and you push that workpiece and on a die. The angle at which you are going to be pushing your die will depend on the type of finish you want. Kama unataka an angle of 60, you will take a die that has an angle of 60. If you want an angle of 30, unachukua a die ambayo iko na angle of 30. So depending on the type of angle you want, you will use the different dies. Now, let us see Now, those terms, we will not talk about them for now, but I want you to at least understand the process itself by seeing it. Yeah? When you know, during mfano ukienda kwa workshop ama when you're doing your projects, you'll just be given a workpiece, and you will be expected to machine that workpiece. If you want to have a corner on your workpiece, you must be able to have, you must be able to bend that workpiece kulingana na whatever you're making. If you want to make an angle of 30, you make an angle of 30. If you want to bend your workpiece cylindrically ama kuna corner that is of circular shape, itategemea na the type of punch that you will use. But that is the process of bending. We have a process known as dip or cup drawing. If I want to make a shape, a cylindrical shape, a cup shape, I will take my sheet or piece of workpiece, I will place it between a concave or a hollow die. Then I will take my punch, whatever I will be using to push the workpiece, and I will push it. Yeah, I will stretch that workpiece into that hollow shape, concave shape, and it will assume, it will take the shape of that punch, of that die, of that cavity. Yeah, that is what we call dip or cup drawing. That is how cups are formed. Bottles, utakuwa tuna flat or a workpiece that is flat. You will use a die and push it into that cavity. This is what I mean. We'll have a flat workpiece. Then you will hold that workpiece using things known as blank holders, so that workpiece that isipote, it has to be held tightly. Then you will take your punch, apply a force and a velocity, and push that workpiece into a cavity in that die that you will be using. So that is essentially how cups are formed, hence the name cup drawing or dip drawing. Now let us see an animation of how that is done. I don't know if you have seen what was happening. Labda imeenda haraka sana na mjaona. But there were sheets of metal that were being pushed into concave holes. And then there is a die that is pushing that sheet of metal into that cavity. And that sheet of metal assumes, it takes the shape of that cavity. That is what we call dip drawing, cup drawing. We have another process known as shearing. This is basically cutting by shearing action. You have your die, your punch, and your workpiece. You push, apply a force, and that workpiece cuts by shearing action. That is what we call shearing. Now, these processes that we have mentioned, there are so many processes in our workshop, but this ambazo nimetaja hapa can be done through cold working, another process known as hot working. What do I mean by cold working? This is essentially working on a workpiece below its recrystallization temperature. Recrystallization temperature is the temperature at which a material, a workpiece, will not form new particles, new atoms. Yeah, this is the temperature at which, a very good example is when you heat a material, just before it melts, it forms new particles through new crystals, new atoms. Now, the temperature before that happens is known as recrystallization temperature. So when you're working on a workpiece below this temperature, this process is known as cold working. Now, cold working has advantages, and one of those advantages is tolerance. Tolerance, sana is, if I'm working on a workpiece and I want to have an accuracy of ±2. Yeah, if I work on it through cold working, then I have an advantage of having a better accuracy. Another advantage is good surface finish. I won't have rough surfaces. Yeah, so when I work on a workpiece, itakuwa smoother. Low cost of fuel and electricity. I won't have to think about heating that workpiece. So my fuel and my electricity will be minimum. And the same as machining. I won't have to worry about filing. I won't have to worry about cutting, because the process itself, I can produce a final product. Yeah? So my machining requirements will be minimum. But there are disadvantages, and such as strain hardening. That is, if I'm working on a metal at kama sahi at room temperature, and I'm heating it, mfano I'm forging, I'm heating my workpiece, that workpiece might become hard from that action of heating it. So inakuwa ngumu. Okay, we will require higher forces because the metal it is in its natural state. So I will require a higher force, let's say if I am forging, to heat that metal as compared kama ilikuwa moto. If it was hotter, I will require less force, but if at cold working, I will require a higher force. And because I'm requiring a higher force, I will require powerful and heavier equipment to do the same work as compared to it if it was hotter. Some workpieces might not be ductile. We had talked about ductility at some point. It might take, some workpieces cannot be machined at room temperature, at below recrystallization temperature. So when you're working on a workpiece, please ensure that you know whether that material can be worked using cold working. Can it be, for example, forging? Can I forge steel and in room temperature? Can I forge iron in room temperature? So you have to take into consideration such things. We have processes, hot working. Now you are working above the recrystallization temperature. Now you're heating the metal to a place that new crystals, new atoms are being formed, but the metal has not melted. This is a temperature above recrystallization temperature, but before the melting point. And some of the advantages is I will require less force to work on that metal. If I am forging, I will require less force to forge that metal. There is no limit on the amount of hot working that can be done. What do I mean? If I'm working on that metal, sasa if I heat it, I do my working, and then I'm not satisfied by the final product. I can heat that metal again and again and again until I achieve the amount, the final product that satisfies that satisfies me, the process that you're doing. So there's no limit. The grain structure of that metal is refined. That is the process of recrystallization. You're forming new crystals, new atoms by heating that metal. So they become finer and finer. Yeah. No residual stresses are introduced. What do I mean? In the previous cold working, we saw that we have strain hardening. The metal, the material becomes harder. It deforms. Yeah? But in hot working, there is no residual stresses. Yeah? If there is impurities in that metal, when I heat it, those impurities will be broken down and redistributed throughout the metal. So they won't be concentrated in one point. Zitakuwa zimekuwa distributed along the metal, around the metal. But hot working also has disadvantages, and this is poor surface finishing. When I heat a metal and heat it, we will see in videos, sasa hivi tu, the metal cracks. The metal forms other materials. It reacts with the air. So the surface inakuwa rougher. It is not as smooth as working during cold working. Yeah? If you continue heating a metal, it's choker. For lack of a better word, fatigue. So when a metal fatigues, it cracks. It forms cracks and it weakens on the surface. Yeah. Another disadvantage of hot working is that there are some metals, and once you heat it, they become brittle. Zinakuwa kama glass. When you heat it and heat it, when you increase the temperature and you do whatever process you're doing, they can easily break. Okay? Dimensional accuracy. Once you hit a metal, any workpiece, it expands. So if you are going to be machining working on a metal, thinking that you are going to achieve, let's say, 10 centimeters by 10 centimeters, the minute you stop hitting that metal, it will contract. When you hit it, it will expand. So it is very difficult to achieve an accuracy, 10 centimeters. So you have to take into consideration those processes when you're doing hot working. Rapid oxidation or scale formation. Yeah? When you hit a metal, that surface will react with the surrounding. If it is air, it will react with oxygen to form a scale. When you hit a metal, you expose it to the elements. So you might find that kuna scale that is being formed, rust being formed. Are we together until that point? Are we together?
Yes.
What I do when I'm teaching online classes, at some point I will ask the class to unmute and say present, so that I know I'm not talking to myself. Yeah? And please, katika hizi lessons, let us use our actual names, because this is how we'll take our registers. Kama sasa Wizi B, siwezi jua wewe ni nani until you use your actual name. Okay, so let us unmute and say present so that I can know we are together.
Present.
I'm glad that I'm not talking to myself. Now, these topics I had given you as assignments. See, not necessarily. Nilikuwa nimewapatia mwende mwandike notes, so I'll just be passing through them. If you had not written some of these notes, go read again, pitia tena, andika notes. Now, today's tutaanza na a metal forming process known as casting. Yeah? Casting. What is casting? I'm sure you have come across engine blocks. Umeifungua gari ukaona engine. Have you ever asked yourself how that engine was made? Kwa sababu engine is a very complex equipment. So you cannot just go buy an engine from a shop without asking yourself how that engine was made. Now, this process of casting is basically you take a metal, you heat it until it melts. You take that molten metal and you pour it into a mold. Kuna kitu inaitwa mold. We will see it right now. You pour that molten metal into a mold into that mold. Once that metal solidifies, it cools down, we will take that mold, we break it. And what we are left with is that solidified metal. Now, that metal will take the shape of that mold. If I had made that mold to be circular, my metal will come out as circular. If I had made it to resemble an engine block, it will come out as an engine block. If I had made it to resemble a piston, itatoka kama piston. This is a process of casting. You pour a molten metal into a mold, you allow that molten metal to solidify. Once it has solidified, you break that mold. You take it apart and you remove that solid object ambayo iko hapo ndani ya mold, and that is what we call casting. Now, the process of casting may be permanent. When I say permanent, I mean the molds ambazo you'll be pouring your molten metal into are permanent. They are solid. They are metal. They can be reused over and over again. But we also have temporary casting ambayo inafanywa tu once. Instead of using a permanent mold, we use sand, mchanga. That is what we call sand casting. And that is what we are going to start with, sand casting. Before we start, I explain what sand casting is. I will play a video so that you can tell me kama mmeiona sand casting mahali. If not, this will introduce us to the process. So let us watch what it is. Now, I will ask if there is anyone in the class ambaye ameipatana na hiyo procedure mahali. Has anyone ever seen that process anywhere? Sana sana, this is the process that we use for if you're making, let's say, materials ama things that are difficult to machine. Ni ngumu sana uende kwa workshop ukachukue machine ukaanza kuchonga chuma ukapata labda engine block. So you will make that mold. Umeona vile ambavyo amechukua mchanga akaweka kwa sanduku. There is a shape. Let's say if I want to make a shape here, a bottle, I will make that shape and then place it in that sanduku. Then I will pour sand on top of it. Ram, ninafinyilia hiyo mchanga mpaka hiyo shape ya sanduku ya chupa imetokea kwa hiyo mchanga. I will then remove that bottle shape kwa hiyo mchanga, open the box, close it again, and then I will provide shimo hapo juu ambapo I will pour that molten metal. I'm sure mmeona mahali ambapo wamemwagilia hiyo mchanga. Now let us look at it in this diagram. This diagram represents sand casting. Yeah, we have a box, a top box, which is known as cope. We have a bottom one, which is known as drag. Okay, this pattern ambayo we want to form is ndio hii hapa. We have this inakaa tuseme chupa. Let us say it is a bottle. We want to form a bottle from molten metal. So what we'll do is we'll take a bottle shape, tunaiweka kwa mchanga, the bottom box tutaweka hapo chini. We will fill that box with sand. When you fill that box with sand, we will pound. We will ram that sand mpaka ikuwe firm in that box. Okay, and then we will provide a hole through which that molten metal will pass through, ama itaingilia hapa. The same process ambayo umetumia kufanya kujaza mchanga on the bottom box, we will do the same for the top. After you are done with that, we will take a hole. We will form a hole through something known as a sprue. S-P-R-U-E. A sprue pin. Utakuwa umeweka kwa mchanga while you are filling your sand. Ukijaza mchanga utaitoa hiyo pin. Utabaki na shimo hapa ambayo you will be able to pour your molten metal. We have a runner. This is the path ambayo that molten metal will flow into your cavity. Mahali ambapo shape ya, the shape, the cavity ambayo that molten metal will take. There are things that are known as cores. We have seen them, the yellow things. If I want to make my cavity ama my whatever that I'm making to have a hole, mfano, I will put that core into that cavity before I pour the molten metal. When that molten metal solidifies, I can then remove this core na nitabaki kwa shimo. Mfano kama hii diagram yetu. This cavity is bottle shape and I want it to have a hole at the bottom. So I will put a core while putting the sand. When I pour my molten metal, it will take this shape. Alafu nikitoa mchanga, I will remove the core and I will have a hole kwa hiyo. Parting line is the point at which you can be able to separate these two boxes, because they are separate. They are identical but separate. The minute you want to remove them, there is a provision which is called a parting line. Yeah, we have a riser. A riser itatusaidia this will help us to know when I'm filling my molten metal kama imejaa kwa hiyo shimo. Sana sana there is a provision hapa juu, imefika mpaka hapa juu. So when I pour my metal, it will fill that hole and then it will continue filling this cavity until it reaches the top before ijaze hapa pia. So when this riser fills, I will know that my cavity imejaa completely. If I'm pouring my metal and this doesn't fill, I will know that there is some space left. So I will continue until this riser ijae. Now let us see the process. There is a particular process we follow in sand casting. Can you hear this is the volume okay? Haijaisha. Class haijaisha. Hata mimi niko na shida ya network. Nilikuwa nimefika wapi before nipote? Casting. Okay. Nikipotea please let me know. Unajua naweza kuwa naongea peke yangu na sijajua, alafu naangalia napata nilipotea kitambo. Pia mimi natumia bundles, so inapotea tu, sometimes itapotea, so if I disappear, text me so that I can know. Now we were at the diagram ya casting. I was explaining these terms. From that video that you watched, tumeona that this sand is being put in these boxes. We have two boxes in sand casting. We have the top one and the bottom one. The bottom one is known as drag, and the top one is known as cope. They are identical in nature. Yeah? So when I am making my pattern, I mean, let's say my pattern, the pattern I want to make is a bottle. A bottle kama hii hapa. I will take my sand, mchanga. I will fill it. Can you see the diagram? Oh, namsemi bana. Okay, let me share. Can you see now? Okay. Now, this is a representation of how sand casting is done. We have a box, the bottom box that is known as a drag, and the top box which is known as cope, C-O-P-E. When I'm making my sand casting, I have a pattern. Mfano, the pattern I want to make is a bottle. So nitachukua the bottom box, the drag, I will fill it with sand, mchanga. And then I will place my pattern hapo. And then I will take my top box, do the same. I will take the mchanga, and then I don't know if you saw kwa video. Sijui kama nirudie video ama tuendelee. Let me know if I can repeat the video so that we can understand this diagram vizuri. Okay. Can you see it?
Yeah.
Okay. Amechukua mchanga, ameweka his pattern, the thing that he wants to make, and then he's put sand on top of that pattern. Yeah? And then anafinyilia mchanga. He inverts and does the same. Hizo. You know, most of the time when you're in a workshop ama ukiwa kwa industry, the spare parts that you'll be looking for hautapata. When you're looking for spare parts, sana you don't find them, but it doesn't mean that whatever you're doing utatupa ama mtaacha. So you actually will have to make the parts themselves. And this is one of that process known as casting. Now, these are known as the cores, these yellow things ambazo anaweka hapo ndani. So mfano whatever he wants to make, anataka iwe na hiyo na shimo ndani yake, ama anataka iwe na hii shape. So he'll place these cores within the pattern. So this is the bottom, and then he will place the top one. It is the similar. Mpaka ameweka mahali pa kumwaga hiyo molten metal. So the molten metal is poured within these holes that have been made. Those molten metals itapita through that cavity that we'll see shortly in the diagram. Once the metal solidifies, it not cooling, not once the metal has cooled, once it solidifies, the casting, the mold, that sand mold is broken so that you can get your casting. The unnecessary parts are removed so that you can get the final workpiece. And this is the diagram, your box. The bottom box, which is known as drag, and the top box, which is known as coop. You will take the bottom box, fill it with sand, and then you place your pattern, whatever you want to make in that box. Yeah, you do the same for the top. Yeah? Unachukua the box, invert, you place your pattern in there, you put your sand, unajaza mpaka, and then make sure while you're filling the sand, unafinyilia hiyo mchanga so that it is firm, it is not loose. If I want to place holes, if I want to place other shapes within that pattern that I'm making, you use cores, those yellow things that you saw. Unaweka ndani your box so that when you're placing the sand, ukitoa mchanga, ama when you're pouring your molten metal, it will assume the shape. It will form that shape with mfano this bottle. If I want this bottle to have a hole hapo chini, I will put a core so that once I pour this molten metal down this hole, it'll take this shape. Now, once I'm done with pouring the sand, I will remove these boxes. Easy boxes, nitazitoa. I will unclamp them and nitabaki na mchanga. I will remain with this sand. Then I will take the molten metal and pour it. This hole is made by something known as a sprue pin. Sijui kama mliona ikianza. He put a pin in this before amwagilia mchanga. So he puts the pin, then he puts the sand. Once he's done ramming the sand, anatoa your pin, so shimo inakuwa formed. That is the hole that you will pour the metal. This riser will help you know kama the molten metal imejaza this cavity ama this space. Sana sana this riser inafika mpaka hapa juu. So once you fill the molten metal, this the molten metal itafika hapa mwanzo, itajaza this space first before it fills this space. So once it fills this riser, you will know that your molten metal has already filled this cavity. If it doesn't fill this space, then you will kutakuwa na spaces, and this will form defects. Those defects I've given you as an assignment. You'll go find out the common defects in casting. Now, there's something known as a parting line. This is a partition that will help you remove these boxes. Itakupatia a guide on which part is the bottom and which part is the top. A runner is the path that will the molten metal will take into the cavity of the mold. The mold is now the sand. Yes. Now, let us look at the process of sand casting. Can you hear the volume? The volume iko sawa? Can you hear hiyo video? Kama hiyo volume ya video haiko clear, let me know so that I can increase it. Okay.
Sand casting.
Unasikia sasa?
Sand casting is the most widely used casting process in manufacturing. The advantage of using sand to manufacture products of metal is that sand is very resistant to elevated temperatures. Almost all metal casting materials can be sand cast. Sand castings can range in size from very small to extremely large. Some examples of items manufactured in modern industry by sand casting process are engine blocks, machine tool bases, cylinder heads, pump housings and valves. Now we will understand the process of sand casting in detail. First of all, on a clean floor, we will set the inverted drag box. Then we will place the pattern inside the box and pour the sand into the box. After that, sand is rammed and leveled off. The packed drag box is then turned over and cope box is placed over it. After that, second half of the pattern is placed exactly over the first half of pattern. Then the sand is filled and rammed tightly. Now two boxes are opened and pattern is removed with the help of screws. Boxes are again put back into position and clamped with the rivets to prevent upper box floating. Gates and spruces are formed to pour the metal. Now the molten metal is poured into the mold. Then it is allowed to cool down for some time. After cooling, the final cast is taken out.
Are we together until that point? If you can hear me, unmute, say present.
Present.
Mmeweza kuona hiyo video na mmesikia? I want to know whether you've been able to hear vizuri. Nirudie tena? Okay.
Sand cast. Sand casting. Sand casting is the most widely used casting process in manufacturing. The advantage of using sand to manufacture products of metal is that sand is very resistant to elevated temperatures. Almost all metal casting materials can be sand cast. Sand castings can range in size from very small to extremely large. Some examples of items manufactured in modern industry by sand casting process are engine blocks, machine tool bases, cylinder heads, pump housings and valves. Now we will understand the process of sand casting in detail. First of all, on a clean floor, we will set the inverted drag box. Then we will place the pattern inside the box and pour the sand into the box. After that, sand is rammed and leveled off. The packed drag box is then turned over and cope box is placed over it. After that, second half of the pattern is placed exactly over the first half of pattern. Then the sand is filled and rammed tightly. Now two boxes are opened and pattern is removed with the help of screws. boxes are again put back into position and clamped with the rivets to prevent upper box floating. Gates and spruces are formed to pour the metal. Now, the molten metal is poured into the mold. Then, it is allowed to cool down for some time. After cooling, the final cast is taken out.
Are we together?
Yes, we are.
Any questions until that point?
Now, up to that point, Wali, what is, so you want to make a shape with the holes inside. For example, you want to make a hollow bottle.
Okay.
How will you manage this? Yet, if you pour, you know, it is going to cover that space all.
Kuna hii kitu nilikuwa nimetaja hapa. A core. Okay? If I'm making, yes. I don't know if you have seen kwa hiyo pattern, when they are placing a pattern, you can place a core in that pattern. That core will fill that space. Yeah? So when you pour molten metal, the molten metal will cover, ama ita solidify around the core. So the minute unatoa hiyo casting ama unavunja hiyo mchanga, utaweza kutoa hiyo core na utabaki na shimo hapo ndani.
So this core is just something that is easily broken. It can be broken easily. So
It's
that
easily,
it out of the metals.
you can remove it. Ni kitu unaweza toa. It's not permanent.
Okay.
Yeah. Any other question? Now, let us unmute and say present. Nijue niko na watu.
Present.
Naona watu wako beach kabisa. It's okay. Aya. Let us continue. Yeah? Now, advantages of using sand casting is, kama umeona examples of things that can be made in kama engine block na valves. So depending on the pattern that you make, before even you go to kumwaga hiyo mchanga, you'll have to make a pattern of what you want to cast. If I want to make a bottle, I'll go make a pattern ambayo inafanana na chuma. If I want to make an engine block, I'll go make a pattern that looks like an engine block. So I can make very complicated shapes. Yeah. You can also use ferrous. You can cast ferrous and non-ferrous materials. I can cast metals ambazo ni ferrous. I can also cast metals that are non-ferrous. Any metal or any material that can melt, ambayo inaweza melt, you can cast it. There is large saving in weight. What do I mean? When you are casting a material, you'll find that there is very little material that is wasted. Yeah? You're making an engine block. I will make a pattern that looks like an engine block. I will make it to the dimensions I want, so I will save in terms of material. Even the casting itself will not be as heavy. As we have seen, the tools that are used in casting are very simple. Sand, a box. We'll even look at them sahi. They are very simple and inexpensive. A shovel, ile ya kuchukua mchanga unajaza kwa hiyo box. Yeah? Size and weight is not a limitation. I can make a casting as heavy as heavy as a car. I can make a casting as tiny as my phone. It does not matter. That is the advantages of sand casting. Now, disadvantages, mfano ni dimensional accuracy and surface finishing. Since it is a material that has been made by hand, sand casting is made by hand, so there are mistakes that will come. You will see them when you're doing when you do the assignment. Defects. You'll see that it's very difficult to have an accurate finish. The surface finishing will be rough. Because of if you make a mistake of not ramming, mchanga yako ni loose, the casting ambayo itatokea itakuwa very poor, itakuwa very weak, the dimensions will be off, so it is That is a disadvantage. It is also a labor intensive process. It is labor intensive. Hiyo mchanga, my friend, you will pound it. Utafinyilia mchanga mpaka ikue firm. If you are lucky enough to be in a workshop ama in a place, in a plant ama industry ambayo iko na machines to do that, then ni sawa. But if you go to a place ambayo you are doing it by hand, then you will be able to, it is labor intensive, my friend. Utachoka. Now, some of the tools that we use in hand casting ni kama shovel, trowels. Let me just show the pictures so that we can have a visual. A shovel, we had seen that in the first video, a casting. This is what you will use to load your sand into those boxes. Okay. We have trowels. If in those holes kuna mchanga ambayo imeingia ndani, you can be able to remove it. It is also used to flatten that surface ya mchanga, finishing the surface of the sand so that you can have a flat surface. You've seen this kwa watu ambao wanafanya masonry ama watu ambao wanajenga nyumba. Wakishaweka ile cement, they use those trowels to make the surfaces flat. We have a lifter. Mfano kwa ile shimo. Let me go back kidogo. Kwa shimo kama hii ambayo umetengeneza ya kumwaga your molten metal, if there is this sand ambayo iko huku imecollapse, it's a very common occurrence. The sand that you use in a collapse into these holes, you will use a lifter to fix those holes, to remove the excess sand that falls into those holes. We have a strike off bar. This, I think we saw it in the first video. Once umejaza mchanga in those boxes, you use it to remove the excess. So you will pass this strike off bar on top of the boxes to remove the excess sand ama the unwanted sand from the boxes. We have a riddle. This, when you are filling those boxes, the first mchanga ambayo unajaza kwa hizo boxes is usually rough. But now the minute unajaza box, you'll use this riddle. Ni kama kichungi. Utakuwa unamwagilia your sand in this riddle, unatingiza so that the sand that comes out from the bottom is fine. Particles ni fine, isikuwe na huge chunks of sand, so that when you are ramming your sand, the final product ama the mold ambayo utapata is compact. Ni kitu ambayo imeshikana vizuri sana. We have a vent wire. This is a very important step in casting. Once you are done with your mold making, umeshamaliza, ushatengeneza mchanga vizuri, imekuwa tight vizuri, you make holes in this let me see. Kwa hii mold unatengeneza mashimo so that when you pour the molten metal, the gases, the hot gases ambazo that will be produced from this molten metal can escape. If you don't provide a place for these gases to escape, they will expand within the mold, within the casting, na zitavunja your casting. You will see the defects, some of the defects in your assignments. So you need to create vents using a vent wire. We have rammers. These are the tools that you will use kufinyilia mchanga. Sana nowadays they use hydraulic rams. But if you go to a place ambayo unatumia, it's purely physical, utakuwa unatumia these rammers by hand. Unagongelea mchanga using these rammers. A sprue cutter ama a sprue pin is that pin that you will use to create a hole through which you will pour the molten metal. You can do this before you fill the sand, so you put it kwa hiyo box and then you fill the sand. Once the sand imejaa unatoa, ama you can put it after ushajaza mchanga. Ama when you've already finished making the sand, imeshakuwa compact vizuri, you can then insert a sprue cutter. But it is advisable to put it before, so that when you're done ramming the sand, unatoa tu. That is what is known as sand casting. Now, we have permanent mold casting. The difference between sand casting and permanent is that the mold is made of metal. And sana we have aluminium, ama steel, ama cast iron as the mold, as the material used to make the mold. Unachukua chuma, una machine, unachonga hiyo chuma, and it gives you a mold ambayo you will pour your molten metal into. The way you saw us making, kwa hizo videos wanatengeneza molds, 2 molds, the bottom one and the top one. You'll do the same with permanent casting, but now you won't use sand, you will use metal. You'll take a piece of metal and machine it. Now we use permanent mold casting for processes ambazo ni we are making many items, batch items. Mfano, I want to make let me see. Are we together? Naona ni kama nimepotea kidogo. Tuko pamoja?
Yeah.
Okay. Now, this permanent mold casting is used for if you want to make unatumia kwa industry ambayo inatengeneza things in batches. If I'm making toys, kwa industry labda they are producing 500 toys a day. That is when you use permanent mold casting. So that mold can be used, it can be reused. In the sand casting, once you make your mold, ukishamaliza unavunja. In the permanent mold, once you put your molten metal into that mold, you can open the mold, you remove your casting, and you can reuse it again and again mpaka its lifespan imeisha. So the metals that we use in we can cast in permanent molds ni kama aluminium and magnesium. Now, an advantage that I think I didn't mention in sand casting is that you can cast metals that have a high melting point, because the sand is resistant to high temperatures. Permanent mold casting has a limitation in such that you cannot cast metals that have a high melting point, because if you make a mold using steel has iko na ile temperature ambayo when you heat it ita melt. So every time if you're using a steel mold, the metals that you are casting that mold have to have a melting point lower than steel. So that is a disadvantage, the major disadvantage of permanent mold casting. Now, the processes of mold casting. Now, this is a diagram that shows how permanent mold casting is done. You have the molds ambazo you have machined. I will please ask, if you're not asking a question, to mute our microphones so that we do not disrupt, ili tuweze kumaliza haraka. Now we have permanent molds ambazo have been machined. So what you do is you will open that mold. Once you open that mold, you will spray the mold inside the mold to lubricate the surfaces, to make the molten metal to enter those molds easily. So you have a mold that is stationary, that doesn't move, and you have a mold that is movable, that can be moved using a hydraulic means. Okay. Once you have once you have opened your mold, you pour your mold once you have sprayed, and if you are going to insert a core, ni sawa. If not, ni sawa, inategemea na the pattern ama the casting you want to make. Once you are done with that, you close the mold. Okay, you pour the molten metal into the cavity ambayo utakuwa umetengeneza. If you're making a toy, the cavity ama the shape ya hiyo mold will be formed once you close it. There's something else you do in permanent mold casting. You preheat. You have to preheat the mold. You preheat and you spray so that the molten metal can flow into that cavity easily. Inaingia kwa hiyo cavity easily. Once you close that mold, you pour the molten metal as seen in this diagram 3. Umeshafunga hiyo mold, you pour the molten metal. Now, the molten metal ikisolidify, you open the movable mold, unafungua, and then you take out your casting. And in this diagram, the casting ambayo umetoa ni figure 5. So you'll take your casting, you clean it, you polish it, you inspect it, you make sure that you get whatever you want. Now, in permanent mold casting, there is a very... Please, let's mute our mics, tafadhali. If you're not asking a question, let us meet our Mike, Callister, Joseph. Haya, there is a defect ambayo kwa please in that assignment ya defects, find out the defects that are common when you use permanent mold casting, and defects when you're using sand casting, so that you can spot the differences. A very common defect in permanent mold casting is once you pour your molten metal into this cavity, once since the permanent mold casting cannot change its shape, it is permanent. Once that metal is contracting, kuna places solidifying, there are places in that cavity that will not allow that metal to solidify vizuri. So you'll find that there are cracks in the casting. When you finish the casting, the final product, utapata kuna cracks. Why? Because the casting is solid. It is permanent. It cannot change the shape to accommodate the solidification process of the casting. So you'll find that there are defects like cracking in the casting. Now, what are some of the advantages of permanent mold casting? It has a good surface finish. Since you have already machined the mold, so the surface of that casting will take the shape, and the surface will be of that casting will take the what am I saying? Itachukua the shape and the surface of the mold, the molten metal. Once it solidifies, it will take the surface, it will take the shape and the surface of the mold. So if your mold is smooth, if your mold has been machined accurately, then the casting, the molten metal, when it solidifies, it will have a good surface finish. Now you can control the dimensions of a permanent mold easily. If you have dimensioned your mold to be 50 centimeters by 50 centimeters, once you pour your molten metal into that cavity, it will be more accurate as compared to when you do it using sand casting. Why? Because that shape will not change. That shape will remain the same. In sand casting, inaweza badilika. You might have forgotten to ram your sand ikakuwa loose. Ama mchanga, the boxes ambazo, those two boxes, ukasahau kuzifunga vizuri. So you can easily control the dimensions in permanent mold casting. Since the mold is permanent, the structure of your casting will be finer. Since you're not going to once the solidification process begins, since the permanent casting is not subject to moving, it is fixed, it is permanent, then the material that is formed when the metal solidifies is fine. And then that means that your castings will be stronger. Zitakuwa more stronger as compared to sand casting. Now, we have some disadvantages of molding, and the main one is that the molding, the casting process is limited to metals that have a lower melting point than the mold itself. If my mold is made of steel, I cannot do casting with a metal that has a higher melting point than steel. Why? That means that it will melt my mold. So the molding is limited to metals that have a lower melting point. The mold is expensive. You can imagine if you are machining a mold ambayo inakaa engine block. You will have to machine a mold that looks like an engine block, which is very expensive because you'll be using steel or aluminium as your mold. Now, since the mold is expensive, you cannot use it to come up with very complex shapes. So it is limited to simple parts. If I'm going to make a mold ya kutengeneza pencil, that is all I can do. If I'm making a mold to produce toys, that is all I can do. It is very difficult to find a permanent mold that will be used to make engine blocks. Why? Because it will be expensive to make that mold, and it is an engine block has very complex parts, has very complex shapes. Ikona corners, ikona curves. So it is very difficult to machine to make such a mold. That's why you use sand casting for those complex shapes. But for simple shapes, kama toy, kama kalamu, we can use this permanent mold casting. These are same types of defects in casting. This is your assignment. Please go find out what they are, draw diagrams if necessary, and submit it by at least next week. You'll find the assignment in the Google Classroom. I've already sent the link. You'll even find the notes. You'll find everything that I'll be talking about. Those books mnazo already. So please use them to find out the common defects in casting. Now, how do we clean these castings? There's are we together? Jo mmenyamaza sana mpaka nashindwa kama naongea na watu. Okay. Now, how do we clean these castings? Umeona katika nashukuru bana. Now, we can kama ile sand casting. Ukishamaliza kutengeneza your casting, umevunja hiyo mchanga, umebaki na ile casting, you'll find that ile gate ambayo umemwagia casting imekuwa formed on the casting. The risers mahali ambapo ulikuwa unaangalia kama hiyo molten metal imejaa, it will be formed on that casting. So there's rough cleaning. Unaweza chukua ya casting. There's a video that I showed you, the first one, ambayo walikuwa na gonga the castings with nyundo to break, to remove those gates and risers, those parts that can be seen that are not part of the casting. We have surface cleaning. You can take mchanga, you can take sandpaper, you can take a wire brush, you clean the surface. Mahali ambapo mchanga imestick kwa casting, scale imeform kwa casting, other materials that can stick on the casting, you can remove by cleaning the surface. Trimming, we'll see shortly. Once you have the casting and there are parts, there are rough edges on that casting that are unwanted, you can take the casting, unapeleka kwa grinder, you can file, okay? You can remove those parts that are unwanted through trimming. And then there is the finishing processes. If you want a very smooth surface, you can polish it, you can buff it, okay? If you want to cut that casting, you can machine it. Unaweza peleka kwa workshop ukatumia saw, hand saw, ukakata. Let's see how an example of the cleaning process here.
YouTube
casting.
This morning we're going to be cleaning up the casting that we made last night. So I'm going to start by cutting the sprue off.
As you can see, he's removing the unwanted parts using a saw.
Okay, so yeah, I ground those off with the grinder. That was a lot easier. Alright, I'm just going to go ahead and reseat this guy again. Check it for true.
The machine he is using to kushikilia that workpiece is known as a lathe machine. Okay, the machine he is using is known as a lathe machine. So ameshikilia the workpiece, and then he's using a cutting tool to machine it, to remove the unwanted excess. These are some of the machining processes in a workshop or even in the industry. If you can hear me, please unmute and say you're present.
Present.
Okay.
Present, sir.
Sawa.
All right, YouTube, here's the pattern, and here's the casting cleaned up with the sprues cut off. Here you go.
No, the pattern is what he used to make the casting. This is what you put in the sand. This is your final product. This pattern can be reused over and over again if you're making multiple castings. Kwa hivyo utaweka this kwa mchanga mara mingi.
Well, YouTube, thank you very much for watching this video of cleaning up the flywheel. I do have a couple more shots here I'd like to share with you after cleaning it up and just goofing around a little bit. If you like what you see here, please subscribe to my channel. As always, any comments would be appreciated. Thank you very much.
I think we have been able to see that there are once you finish making your casting, itakuwa na hizo rough edges. We still have the sprue still attached to the casting, so you have to remove those unwanted parts from your final product, so that when you're presenting your final product, mfano umefanya casting ya spare part ya gari, ama spare part ya electrical component, so you have to remove those unwanted parts so that you can remain with the final product. Tani mute Callister juu anakataa ku mute. Okay, now how do we make sure that the casting that we have produced is of standard? Labda umefanya casting and it is very weak, it cannot withstand the stresses ambayo unataka ku subject it to. So we can inspect those castings by two major methods, and the first one is non-destructive methods. Maybe in my casting internally I have cracks and I have defects, and I cannot see these defects with my naked eye. So what I do mfano is I can take an X-ray of that casting, radiographic inspection. Napeleka casting, inafanywa X-ray, and then from the picture that I get, I can see that internally I have cracks, that kuna defects within the casting. I can also use dye penetration. What do I mean? I can take a colored liquid and apply it on the surface of the casting. Places that have cracks, places ambazo zina grooves, will retain that dye once I clean it off. Unaweza chukua dye unaiekelea kwa the workpiece, and then I wipe it off. The places that have cracks hazitafutika. The dye will remain at those points. So those are types of non-destructive methods. Now, destructive inspection methods are used when you want to test the strength. You will literally break those castings to see at what point and at what force that casting will break. This sana we use it when you are making castings for processes. I mean for equipment that will undergo large forces. If I'm making a casting to replace kwa gari, kama mfano netwaje suspension rod ya gari, if I have to know at what point at what load that casting will break, so I will subject it to tests kama breaking, to tensile tests, to compressive stresses, to see at what point that casting will deform or will permanently deform. Let's see. Yeah, I think we'll stop our class for today.